Here's integrated 3. This is problem 9-101, and it says the CPM amusement park has decided to imitate the Screamer, but wants to make their ride even better. Their ride will consist of a circular track, which will, with a radius of 100 feet, and the center of the circle will be 50 feet underground. And passengers will board at the highest point. So they will begin with a blood-curdling drop. So they're going to go down like this. Write a function that relates the angle traveled, and then they put in in italics, from the starting point to the height of the rider above or below the ground. So I didn't listen to the italics, and the first time I did the problem, I did it. I said at 0. I was using the positive. Well, this isn't really the x-axis, but I was using down here as my starting point. But really, I didn't listen. I didn't pay attention to what they said. They told me I need to start up here and then start measuring my angle. We usually measure angle measures from the positive x-axis, so we go 90, 180, 270, 360, or you could say pi over 2, pi, 3 pi over 2, and 2 pi. But they don't want me to count it that way. They said from the starting point, and they said they're going to start at the highest point. So what I want to do is I need to make a, we just learned this today. We've got y equals a times sine of x minus h plus k, or it could maybe be y equals a times cosine x minus h plus k. I want to make an equation that describes this. So something has happened to my unit circle. My whole unit circle got moved down by 50, so I'm pretty sure my k is going to be negative 50. I think I'm going to actually have to just plot some points and make a graph to figure out. I feel like this pi over 2 is going to play into this somehow as a shift. And then a is the amplitude, and I know that the amplitude is from the middle to the top or from the middle to the bottom. So it's actually, they said the radius is 100, so that's going to be 100. But let's go ahead and plot some points. So I have to start here. This is where I'm going to get in the little car seat. So at 0, like when I haven't moved through any degrees, I'm 50 feet above the ground. There's the ground, and there's this is underground down here. Okay, so that's why I wrote 0, 50. And then even though I started at pi over 2, if I move through an angle of pi over 2, which is just a quarter of the circle, how high from the ground, how far from the ground am I? Well, I'm 50 feet underground, so I wrote negative 50. And then even though I'm at pi, I've only moved pi over 2 so far. And then so when I do this other quarter circle, I'll have moved pi. And I am at negative 150. So let me count again. That's 1 pi over 2. That's 2 pi over 2. 3 pi over 2, like the third quarter of a circle, the third quarter of the way around, what's my height from the ground? I'm 50 feet underground. And then the fourth, the last, quarter circle, I'm going to be 50 feet above the ground. So the way I'm counting my angle is I'm going, if I start here, I'm going 1 pi over 2, 2 pi over 2, which is pi. This one becomes 3 pi over 2, and then that's 4 pi over 2, which is the same as 2 pi. Like fraction math, 4 pi over 2 is 2 pi. So that's what they want on the table, and then I just drew a graph. I just drew an x and a y axis, and I see that my x's are just going from 0 to 2 pi, so I just like evenly spaced pi, 0, 2 pi, and then I put these values in here. And then I want my y to at least go up high enough to fit my points, so I just put it up to 100, and my lowest point's negative 150. And then I'm going to plot the points. So 0, 50 ended up there. Pi over 2, comma, negative 50. And then pi, comma, 150. And then 3 pi over 2, comma, 50. And 2 pi, comma, negative 50. And 2 pi, comma, 50. So when I looked at it, this whole time I was thinking I was going to use a sine graph. But I remember everything that we learned today, and sometimes a cosine graph is actually a nicer way. This looks more like a cosine graph, like my locator point is one of the high points. So I'm going to use cosine for this. So then I go y equals a times cosine x minus h plus k. Well, I already said k was going to be 50. It's moved down by 50. The amplitude's 100 because from the middle to the top of the wave, that's 100, right? I mean, it's 200 all the way down, but that's my amplitude. And then it's not shifted because my locator point's still on the y-axis. So this is actually the answer that they wanted. You could have also done it with sine, but then you would have to imagine that sine got shifted a little bit, because you'd need to shift it by, how much? Pi, I think. Let me check on that. 101. Yeah, you'd have to shift it by pi over 2 for it to be a sine graph. So anyway, I used cosine though. That's it.